Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. RADHA SUBRAMANIAM with a PhD in Chemistry. So already I have uploaded the first part of the most important MCQs of the lesson, redox reactions. Today I am going to continue with the second part of the most important questions. So before I start with today's unit, I would like to share with you that we were discussing about how to proceed with the inorganic chemistry portions. So once you finish off with the periodic properties of elements, then start with S block and P block elements for both class 11 and 12 and D and F block elements. And as I already said that all the questions from this chapter are direct questions and you need to be thorough, in fact, word by word with NCERT. You learn all the reactions, learn general group trends, focus on exceptions, focus on oxo acids, and after this you can take up chemical bonding and molecular structure. And here the important points to focus are hybridization, VSEPR theory, dipole moment, bond parameters, molecular orbital theory, hydrogen bonding. And after this you can take up coordination compounds and focus on double salt with example, nomenclature, isomerism, crystal field theory and valence bond theory, magnetic properties. The remaining chapters can be prepared where you have to learn all reactions from hydrogen, focus more on hydrogen peroxide, learn different separation and concentration techniques from the isolation of elements chapter, and important pollutants from environmental chemistry and their reactions. So after you finish all the main important topics from the textbook, then you have to practice the MCQs, most important MCQs, and repeatedly keep on refreshing the portion so that you won't forget it for your exams. Okay, now we will start with the first question of today. What is the oxidation state of N, nitrogen in NH4NO3 in order? So is it -3, 5, 5, -3, 5 or -3? So NH4NO3 is the compound. So option is A, that is -3, 5. So when you divide the two parts of oxidation number of N in NH4 plus, it is, we can divide it as, here we will take as X and then the second part as X plus 4, and for one hydrogen atom it is 1. So into 1, that is equal to, because here see NH4 plus, it is an ion. So normally you put this part is equal to 0, but here in this case, since this is an ion, the one plus charge is given, you just put it instead of 0, you put that is equal to plus 1. So X, and since 4 hydrogen atoms are there, you put X plus 4, and for one hydrogen atom it is into 1. Okay, so what, how will you do the calculation? X plus 4 into 1, 4, that is equal to 1. So X plus 4 is equal to 1. So X will be equal to 1 minus 4, which is equal to -3. So oxidate, we are finding N, we don't know, that is why we are asked to find out the oxidation number of nitrogen. Since we don't know this, we just take that as X. For nitrogen we take it as X because we are going to find out. And for hydrogen H4 part, we have to take it as X plus 4 into 1 hydrogen, it is 1. So 4 hydrogen, that is 4 into 1. Okay, so when you solve the equation, you get oxidation number of NO, oxidation number of nitrogen. In this X we get it as -3. Then we have to find out the oxidation number of N in NO3 minus. Suppose we take this value here as Y. So Y plus 3 into, for 1 oxygen it is -2. So for 3 oxygen it is 3 into -2. See here one negative ion. So that is equal to put -1. Y into -6 is equal to -1. Y is equal to -1 plus 6, which is equal to 5. So the oxidation states of nitrogen in this compound will be -3 and +5 respectively. I hope you understood this clearly. Okay, now next question. What is the oxidation state of sulfur in Na2S6O6? So you are asked to find out the oxidation state of sulfur in this compound. Is it 5, 0, 5 by 2 or 2? So option is C, 5 by 2. So here the average oxidation states of elements in compound, that is the average of different oxidation states. So average oxidation state of sulfur in this compound Na2S6O6 is, so X into 2 into 1, okay, plus 4 into X plus 6 oxygen atoms, 6 into minus 2, the whole thing will be equal to 0. So 2 plus Na2, see why we are taking as 2 into 1 Na2. So for 1 sodium it is 1, so for 2 it is 2 into 1. So we are, since we are finding out x, you have to put it as x into 2 into 1 plus 4 into x, sulfur we are going to find out, plus 6 into minus 2. So what you get from here is 2x plus 4x plus minus 12 is equal to 0. When you solve this equation for x, you get x is equal to 5 by 2. So remember, I think you know how to solve the equation. That is 2x plus 4x is 6x is equal to minus 12. X is equal to 6x is equal to, sorry, plus 12, because when you move this minus 12 to opposite side, it becomes plus 12. So 6x, from that you just solve for the equation, and finally you will get 5 by 2. And later on in another video I will show you, for those who are having doubts on how to solve these equations, I will show that as a separate video, because we need not waste our time moving on into deeper concepts of how to solve all these equations now. At this stage I will show it in another occasion. Okay, next question. What is the stock notation of cuprous oxide? Is it copper oxide, copper 1 oxide, copper 1 or copper 2 oxide? Okay, how do you write it? Option B, you write it like see, like this, in this way. Okay, so why? Elements exhibiting different oxidation states are denoted by Roman numerals. Remember that, like this. Within parenthesis, after the symbol or name of the element is like this. How you write that? You call it as stock notation. So you have to write it in Roman numerals within brackets. Parenthesis means brackets after the symbol or name of the element. Okay. Now S plus O2 gives SO2. That is an example of, is it combination, decomposition, disproportionation or double decomposition? Answer is option A, combination, because sulfur and oxygen combines to give sulfur dioxide. So what is chemical combination? When reactants react to give you products. So above formation of sulfur dioxide from sulfur and oxygen is a type of combination reaction. Now here, what is this equation? It's an example of water. You get hydrogen and oxygen. Is it combination, decomposition, disproportionation and double decomposition? Answer is option B. It is decomposition, because hydrogen from water it is splitting to give you hydrogen and oxygen. So actually this is a reverse of combination reaction. In decomposition reaction, the breaking down of a compound happens into two or more substances. So water is broken into hydrogen and oxygen. So it is a decomposition reaction. Now the exchange of salt between zinc and copper is an example of combination, decomposition, disproportionation and displacement. Answer is option D. Option D is displacement reaction, because an ion in a compound, it is if it is replaced by ion of other element, it is a sort of displacement reaction. But here the ions are salts. The exchange of salts between zinc and copper is an example of displacement reaction. Okay, now breakdown of hydrogen peroxide into water and oxygen is an example of combination, decomposition, disproportionation or double decomposition. Answer is option C, disproportionation. Why? Because in these type of reaction, these are special type of redox reaction. Here a single compound undergoes oxidation and reduction simultaneously at the same time. So breakdown of hydrogen peroxide into water and hydrogen, same thing happens. Then this reaction X plus YZ gives XZ plus Z. It is a form of combination, displacement, disproportionate or decomposition reaction. Option is B, displacement reaction. So here in displacement reaction, a metal or a non-metal in a compound, it is replaced by another metal in uncombined state. See, this is uncombined. So this is replaced by, see, Z and X combines together, leaving out Y. Okay, so X Z plus Y here, it is wrongly given as Z. It is a displacement reaction. Now can ClO4 exhibit disproportionation reaction? Maybe yes, no, cannot see. Answer is C, that is no. Why? Because these ion, it cannot show disproportionation reaction, because chlorine in ClO4 minus is present in its maximum oxidation state, that is plus 7. So the reaction occurs only when it is present in its intermediate oxidation state. Okay, now next equation, 2F2 plus 2OH minus gives 2F minus plus OF2 plus H2O. What type of reaction is this? Is it combination, displacement, disproportionate or decomposition reaction? Answer is C, disproportionate reaction. Because disproportionate reaction occurs when an element in a compound, after reaction, it splits into two different oxidation states, that is simultaneously at the same time it is oxidized as well as reduced. So here fluorine is reduced as oxidized as well. So both reaction taking place, it is disproportionate reaction. So which of the following reaction is a combination reaction? X plus y z gives x z plus y, 2F2 plus 2OH minus 2F minus OF2 H2O, 2NaH gives 2Na plus H2, or S plus O2 gives SO2. Combination. Here you can see what is combination reaction. See, S plus O2 gives SO2. Only this is combination reaction, because the others are all disproportionate reaction. So, and here NaH, Na plus H2, that is a decomposition reaction. So, with that we are coming to a conclusion of this important MCQ parts of redox reaction. I will be coming with a separate section on how to solve numericals, because when you are talking about MCQs and choice making, so here I cannot write it and show it to you, so that I can do it as a separate video on solving the problems. So those who don't find this clear enough to understand, you will understand the concepts clearly when you, and I'll just write down all the sums and work out for you in another separate video. So please do like, share and subscribe to my channel, share it with your friends. Also don't forget to press the bell icon, because as soon as I post new videos, you will get the notifications immediately. Thanks for watching the video. I'll upload another session quite soon.